Okay, in this video we're going to look at the quotient rule, and the quotient rule is used to differentiate functions which are rational expressions, that is, one function divided by another. For example, here's two situations where you've got one function divided by another. Here we've got x squared minus 6x plus 3 on the as the numerator, and as the denominator we've got 5x plus 2. So two different functions there, expressed as a rational expression. Next one, same sort of deal. We've got e to the power of 3x plus 8 in the numerator position, and in the denominator position we've got cos x minus 6. So it's one function divided by another, fraction form. Okay, so if you look at that situation, we've got a rule that applies to differentiation of a quotient. Okay, one function divided by another one. So if we've got that situation, we're going to label one of the functions u and the other v. And the quotient rule is this: that the derivative is the function in the denominator position multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator over v squared. Okay, so it's got three distinct parts there. Let's do a before I go on, if we've got the form f of x, we can call the two functions u of x and v of x, and same sort of rule applies. Numerator multiplied by derivative of, denominator multiplied by derivative of numerator minus numerator multiplied by derivative of denominator over denominator squared. Let's give it a go. I'll put the rule here over to the side, the quotient rule, so we've got it to refer to as we go. So here I'm going to label one of my functions u and the other one v. So let's start with that. So u equals 3 minus x, and v is x squared plus 4x. So straight away what we're going to do is get the derivative of both of those. So du dx is going to equal negative 1. That's because the derivative of 3 is 0, the derivative of neg x is neg 1. And dv dx equals 2x plus 4. So there we go. We've got our originals there, our u and our v, and our derivatives. So now we're going to apply the rule. Okay, so here it is. And dy dx is going to equal v, which is x squared plus 4x. Good idea to bracket these. Multiplied by du dx, which is negative 1, minus u, which is 3 minus x, multiplied by dv dx, which is 2x plus 4. That's the derivative of v. And over, all of that goes over v squared, which is, let's make it a bit straighter, it's better. V is x squared plus 4x, so it's x squared plus 4x all squared. Okay, time to tidy things up here. First of all, we're going to look at this section here, x squared plus 4x times negative 1, and that's going to be negative x squared take 4x. Now we've got to remove these brackets, and what we're going to do here, the brackets here, we're going to leave the negative where it is, and then we're going, keep doing that, leave the negative where it is, and we're going to remove these brackets. So we get 12, 3 fours, 3 times 2x is 6x, so that's plus 6x. We get minus 4x there, and then we get negative x times 2x is negative 2x squared. Okay, and that's going to go all over x squared plus 4x all squared. Now remember, very important here, that I'm getting the negative of all of that. Okay, I must make sure I put those brackets in, because if you look at that negative there that I've just ticked up the top there, we're minusing that expression with the red box around it. So it's very important that I do that, and now I'm going to remove that bracket and make sure that the negative is applied to every bit there along the way. Right, so it's negative x squared minus 4x minus 12. Now I'm going to do one step here, or two steps in one. So 6x minus 4x is going to be 2x. Then if we get the negative of 2x, it's negative 2x. And then I've got minus 2x squared. Sorry, the minus of negative 2x squared, which is plus 2x squared. Right, so along the top there, things are looking alright. So put our denominator in now. And we've got x squared plus 4x squared. Alright, time to tidy up the top of this expression in the numerator. So we've got, let's look at our x squareds. We've got 2x squared and we've got negative x squared. Okay, so that gives us a total of x squared. We've got negative 4x minus another 2x. Okay, that's negative 6x squared. Negative 6x. And we've got only the one number there, minus 12, over. Now I'm going to tidy out the bottom a bit, because what I'm going to do is take out a common factor here on the denominator. So what we've got is, we've got set up a square bracket here. The denominator is x outside of x plus 4. That's one we've talked about a bit about this year. Sometimes it can escape our attention, but x outside of x plus 4 squared. That's going to equal x squared minus 6x minus 12 over, now if I remove the square bracket now, we get x squared times x plus 4 squared. And we're done for that problem. We've used the quotient rule. Okay, remember what the quotient rule is. It's one that we use over here when we're dividing. We've got the division of two functions. Okay, so we've got a quotient. There we go. More complex one now. One's involving e to the power of expression, and also a trig function there as well, cos 2x minus 3. So let's start. Now, this one's in the form of f of x, but I tend to still use u and v, like I did in the last question. Just at the end, the answer becomes f dash x. So it doesn't really matter if I use this terminology along the way, dy dx, as long as when I'm finished, then it's f dash x is the derivative that we're after. Alright, so u is 2e to the power of 3x. V is cosine 2x minus 3. So du dx equals, remember the derivative of 3x comes out the front, which is 3, and gets multiplied by the 2 to give 6. E to the power of 3x, the index doesn't change, to v dx. The derivative of cos is neg sine. Okay, so it's a negative out the front there. We get the derivative of the bracket. Derivative of 2x minus 3 is 2 sine, and bracket stays the same. There we go. So we've got our u, our v, our du dx, and our dv dx. Time now to apply the quotient rule, which is up here. Okay, so dy dx equals v cos 2x minus 3 multiplied by du dx, so multiplied by 6e to the power of 3x. minus u, which is 2e to the power of 3x, multiplied by dv dx, which is negative 2 sine 2x take 3. Squeeze it in there. All over v squared, okay, and that's going to be the square of that. Remember our terminology for that is that it's cos squared 2x minus 3. Alright, we'll move on from there. Let's tidy up the numerator now. Equals, bring the 6e to the power of 3x out in front of the cos 2x minus 3. Here we've got a multiplication, we've got a negative 2 times a negative 2, so we've got a plus 4e to the power of 3x sine 2x minus 3 over our denominator, which is cos squared 2x minus 3. Now if you look closely up there on the numerator, we've got a common factor. We've got 6e to the power of 3x here and 4e to the power of 3x there. So taking out as a common factor there in the numerator, we can take 2e to the power of 3x, and then if we divide that into both this expression here and this expression here, we get 3 cos 2x minus 3 plus 2 sine 2x minus 3. And that's over cos squared 2x minus 3. That's it. We can't go any further with that. There's nothing that can be cancelled or anything there, or factorised any further. So that, everybody, expression here, that is our answer. I wanted to do this one here because it can be used as a quotient rule, because it is a quotient. But I wanted to demonstrate here how you can actually do this one alternatively, and sometimes easier, I think, by using the product rule. Okay, and you remember the product rule was dy dx equals u times dv dx plus v times du dx. Okay, so recall that we've done that before in class just recently. So what I'm going to do here, instead of using the quotient rule, which has denominators and it's got negatives and it's a bit messy, doesn't mean you can't use it, but sometimes you're given a choice. For example, if I look at this one, it actually becomes this if I convert it to index form, which I should before differentiating. But then I can actually make my function this. By bringing that x to the power of a half from the denominator to the numerator, it actually becomes negative a half. I've now got a product. And in my product, I've got my u, which is x squared minus 5, my v, which is x to the power of negative a half. So my du dx is simply 2x. My dv dx is a bit trickier. It's negative a half x to the power of negative 3 on 2. So we're going to take this as a product rule question, and we'll proceed with it now using that instead of the quotient rule. Now you can go off by yourself and use the quotient rule for this and just see the level of difficulty and whether you think it's easier to manage than the product rule. So we'll continue on from here. So here we go, we're going to use the product rule. So it's u, which is here, times dv dx, which is here. No, sorry, it's all of that up to there, including the power of negative 3 on 2. So here we go. It's in fact, what I'm going to do here, just to save a little bit of time, I'm actually going to put the dv dx part first. So dy dx equals u times dv dx, in which I'm going to put the dv dx part of it first, times the u, x squared minus 5, plus v, which is x to the power of negative a half, multiplied by du dx, which is 2x. Let's remove brackets here. Now, when we are multiplying with indices, we add them, so we get negative a half x to the power of negative 3 on 2 times 2 is a half. And then if we multiply by the negative 5, we get negative times the negative is a positive. We get plus 5 on 2, x to the power of negative 3 on 2. Then if we multiply these two together here, this side, we've got 2x multiplied by x to the power of negative a half. Now remember, 2x is 2x to the power of 1. So we've got plus 2, 1 plus negative a half is a half. So, got 2x to the power of a half. Now we've got two terms here that have got x to the power of half in them. We've got this one here and also this one here. So we've got negative a half x to the power of a half plus 2x to the power of a half. So we can add those together, and that gives us negative a half plus 2 is 3 on 2. 3 on 2 x to the power of a half plus 5 on 2 x to the power of negative 3 on 2. Got this problem to here now. So what I'm going to do is express things now with positive indices. In fact, I'm going to do something else here. I'm just going to set this out slightly differently. 3x to the power of a half on 2 plus 5 over 2x to the power of 3 on 2. So I've expressed with positive indices. Now I'm going to get this over a common denominator. And the common denominator is going to be 2x to the power of 3 on 2. Now we've got this term here, 5 over that, so that's okay. That's already there. So I can lock in the plus 5 over here. But on the left here, okay, this is only over 2. It's not over 2x to the power of 3 on 2. So I've got to multiply, I'll go off the side here and do it. We've got to multiply 3x to the power of a half by x to the power of 3 on 2. If I do that, 3x a half plus 3 on 2, I'm adding the indices because I'm multiplying, that's 4 on 2, which is 3x squared. So I get 3x squared plus 5 over 2x to the power of 3 on 2. That looks like a negative. Last step equals 3x squared plus 5 over 2. Now we've learnt earlier that x to the power of 3 on 2 is the square root of x cubed. So there we go. That's a more complex one. Now just going back to the original question there. Remember it was x squared minus 5 over the square root of x. What I did was, on the face of it it's a quotient rule problem, but I've made it a product rule problem by multiplying the two functions together. Okay, and operating from there. Now that looked quite complex. It took us a while, didn't it? And what's worth doing now is an exercise whereby you try it with the quotient rule. Personally, one like that, I prefer to use the product rule, but it's up to you. Last question for this video on the quotient rule. Find the gradient of f of x equals 2x minus 3x squared over log 3x plus 4 to the base e. At the point where x equals 1. And we know by now that to find the gradient at a point, we substitute the x-coordinate into the derivative. So first thing we have to find out is the derivative. So if we look at our expression here, our u is going to be 2x minus 3x squared. Our v is log 3x plus 4 to the base e. Our du dx equals 2 minus 6x, the derivative of that. and dv dx, remember our rule for logs, it's the derivative of the bracket, which is 3 over the bracket itself, which is 3x plus 4. So we're ready to go now with this one. On to the next slide. Applying the quotient rule now, we get v, which is log 3x plus 4 to the base e, multiplied by du dx, so multiplied by 2 minus 6x, minus u, which is 2x minus 3x squared, multiplied by dv dx, which is 3 over 3x plus 4, all over v squared, which is going to be, oops, sorry, it's going to be log 3x plus 4 to the base e squared. Now, to be honest, we go to a lot more work in simplifying this, but really, if we go back to our question, we're trying to find the gradient, okay, find the gradient at the point where x equals -1. So, we can substitute, now we've got that expression, we can substitute that in now, that -1, and it just saves a bit of time. And if this was in the non-calculator section, we might go a few steps further with this to simplify it, but really, we can actually start putting x equals -1 in now. So let's do that. So when substitute x equals -1. So let's put -1 in there. So we get log, and we get 3 times -1. 3 times -1 plus 4, multiplied by 2, minus 6 times -1, minus 2 times -1, minus 3 times -1 squared, times 3 over 3 times -1 plus 4. Okay, so I've gone across there and put in -1 everywhere. Of course, we mustn't forget the denominator, which is going to be log 3 times -1 plus 4 squared. There we go. Simplifying further now, we get log, now if you look at this, 3 times -1 is -3, plus 4 is 1, so it's log 1 to the base e, multiplied by, so looking at this bit here now, 2 plus 6 is 8, okay, now we should realise now that, we'll get that in a moment, but you should realise that log 1 to the base e is 0, but we'll get back to that in a sec. Minus, so let's look at what we've got across the top here. We've got minus of -2 minus 3 multiplied by 3 over 3 times -1 plus 4 is going to be 1, so therefore we're going to have something quite simple there in a moment. In our denominator, we're going to have log base e, 3 times -1 is -3 plus 4 is 1 squared. Okay, equals, well, we know that log 1 to the base e is 0, which is going to make all of that 0. Okay, so we get 0 there. We get a negative multiplied by -2, -3. That's going to be positive 5 times 3 there, so we're going to get 15. Okay, now, thing is, on the bottom, on the denominator, we've got naught squared, so we're going to get naught there as well. Okay, so we've got a situation here where it's 15 over naught. Okay, so that's undefined. Okay, so no gradient. Gradient is undefined at x equals -1. I probably wasted, I mean, I didn't do the answer to this question first, but I probably wasted a lot of time there. I probably should have gone straight to that denominator when you think about it, okay, and seen that straight away, and predicted ahead that that was going to be 0. And as soon as 0 is in the denominator, it means that our answer is going to be undefined. Okay, so there's some questions on the quotient rule, so you can now have a go at exercise 7i. Have fun.